Hello guys, welcome to my YouTube channel Play with Science and Technology. So in this video, I am going to share uh, my solution for problems A and B for the recently occurred Codeforces contest, namely Codeforces Round 906 Div 2. So in the first problem, that is problem A, Doremy's paint 3, we are basically given an array of n positive integers, and we have to basically uh, like check whether we can permute the elements of the array such that the resulting array becomes good. And the definition for the good array in this problem definition is that uh, the sum of every two adjacent elements should be same. So let me explain the problem. So in the first problem, we are given n positive integers, and in this basically uh, we have to uh, see whether we can generate a new array such that the new array becomes good. And the definition for good array is that the sum of every two consecutive elements, that is should be equal to sigma I is equal from 1 to 2 of sum should be equal to sigma I is equal to 2 to 3 should be equal to this way, sigma I is equal to n minus 2 to n minus 1. Okay, so the sum of these two elements, these two adjacent elements, should be the same value k. Okay, so so in this example, the range of test case is between 1 to 100, and the range of n, that is the size of the array, should be between 2 to 100, and the value of the array element can be between 1 and 10 to the power 5. And we have, and if we can arrange the elements of the array such that the resulting array becomes good, then we have to print yes, otherwise no. We can the in this the n is not that big, but still we will be able to solve this problem using big of 1. I will be showing you how we can do that. So let me take like different test cases and show how to solve this problem. So let me generate some special cases for solving this question. For case 1, if n, that is the size of the array, is 1, then that particular array will always be good. Okay, this array will always be good because there are not any two adjacent elements to compare. Same here too for test case 2, and if the size of the array is 2, for example 8, 9, then this is a good subarray. So here we will directly print yes, it is a good subarray. So in the next, so our actual problem solving will start from n greater than 2. Okay, so consider one example here, 1 1 2. So in this case, as you can see, originally the sum of these two elements is 2 and the sum of these two elements is 3. So this is not equal. So we will see whether we can arrange and get the final array as good. So if we swap the positions of 0th index and 1th index, then we can find that the resulting array is good. So you can see on rearranging the positions of 1 and 2, we can get the new array as good. So 1 2 1. So here you can see the sum of these two is 3 and the sum of these two is 3. So this is what the problem says, and the way we will be solving with n greater than 2 is like this. The resulting array will be good only if the number of distinct elements in the array is good, is at most 2, and the difference of the count of two distinct elements should not be greater than 1. So let me show you what I mean to say. Suppose we have n is equal to 4 size. Okay, so if I write, so this is the current element. So here we can see that there are two distinct elements, that is 2 and 3, and the count of 2 is equal to 3, count of 3 is equal to 1. So difference here, the difference is equal to 3 minus 1 is equal to 2. So in this case it will not be possible to generate any such permutation such that the final array becomes good. Let me show you with proof why is this so. So consider two distinct elements A and B. Okay, so if we take so in this particular case I am only assuming that the number of distinct elements is only 2, and so here you can see if we first try to do A, I am assuming here that there are two distinct elements. Try to put the next element as A on A, then there will be some point there will be where there will be an element B, right? So if I and we can see that here the sum is 2A, and just before B at some point there will be A. So as you can see that this way it will not be possible to generate a good array, right? Because here the sum is 2A and here the sum is A plus B, and A is not equal to B. So so the the array can only become good if we like place elements A and B alternatively one after each other. For example, if we take here A, then the next element should be B, and since this sum is B, this particular sum is B, the next two adjacent element sum should also be B, A plus B. For that to happen, we have to place the next element as A, and again this sum is A plus B. For again next two adjacent elements sum to become A plus B, we again have to put B, and this way we will go A plus B, B plus A. So here we can see that the count of B is all 3 and count of A is 3 as well. So here the difference is 0, which is less than 1, less than equal to 1, which is satisfying our original what I have told already earlier, that for two distinct elements to form a good array, the count of two distinct elements difference should not be greater than 1. Okay, and it will be 1, it can be 1 in case of odd length array. For example, if there are 2A and 3B, then A B A B A. Here you can see the count of B is 2 and the count of A is 3, and the difference is 1. But it cannot be great. It cannot be like the difference can be. It cannot be that the difference is 2, because if we take 2A and 4B, then it is not possible. As you can see that if we try to do first B, then we can't put here B, because if we put here B, at some point there will be A, right? At the first occurrence where the A is present, just before that B will be there. Okay, and here the sum is B plus A, and here the sum is 2B, and since B is not equal to A, 2B is not equal to B plus A. Okay, I hope you would have got So what observation we derived for two distinct elements having element set is equal to A, B, where A is not equal to B, the difference of count of A and count of B should be less than equal to 1. Okay, I hope you would have got. Now let me show you that for case for more than two distinct elements. This is case number 5. So let's assume uh, there are at least three distinct elements A, B, C having different counts. Count of A is C1, count of B as C2, count of C as C3. So in this case, as I already told that for two distinct elements, all the elements should be aligned, like placed alternatively to each other, like A, B, A, B. If we go this way, and at some instances there are since C3 is greater than 0, it is count of C is greater than 0, then there will be C present somewhere. Okay, but just before C, either A will be present or B will be present. And here we can see that the sum should be A plus B. And in either of the case, A plus B is not equal to A plus C, or A plus B is not equal to B plus C, right? Since since A is not equal to B is not equal to C, right? So A plus B will not be equal to A plus C, and A plus B is not equal to B plus C. So it will not be any permutation of the array having at least three distinct elements will not generate any good array. Thus we have proved that. Okay, so let me now wrap up this question by giving you some pseudo code for the above algorithm. So what I will do is, I will, if the size of the element is less than equal to, let me write here pseudo code, less than equal to 2, then we will have to print yes. Else if n is greater than 2, then what we will do is, we will declare one map, right? We will declare one map so in this map, what we will do is, we will store the first value as different integers which are present in the array, distinct integers which are present in the array, and the second value as the count of those distinct elements. And if the and the size of the map will determine the number of distinct elements present in the array. Let me write here count of size of my map will give the number of distinct elements present in the array. So now if my map dot size is equal to 1, then we will print yes, because if there are only one element, uh, then the sum of two adjacent elements will always be the same. For example, suppose all the elements has a value. As you can see, the sum of every two adjacent elements will always be 2a, right? So now else if my map dot size is equal to 2, then it may not be possible to arrange the elements of the array such that the result final array becomes good, or it may not be possible, or it may be possible. Okay, so how we will determine that? What we will do is, as already proved earlier, we will basically see the difference of the count of two distinct elements. If the difference of the count of two distinct elements is less than equal to 1, then it will be possible, else it will not be possible, right? So here let me take the iterator in the C++, my map dot begin, take the second iter, this is the first iter, this is the second iter, assign it to the same so that we can advance it by 1. We will now increase the iterator 2 by 1 so that it points to the second distinct element, and now we will find the difference. The difference will be the absolute value of iter 1 second minus iter 2 second. So this will basically give the count of difference of the count of two distinct elements. Now if difference less than equal to 1, print yes, else print no, right? Now you close this particular else if as well. Now finally, if now in the third case, the my map dot size will be greater than 2, that is the number of distinct elements is greater than 2, and in that case, as explained here, for more than two distinct elements, it will never be possible to arrange the elements of the array so that the final array becomes good. Okay, so in this case we will simply print no. So this is my solution. Let me show my submission in Codeforces. I hope you can see that. So this is my submission. Here you can see that I have, let me zoom it. So here you can see that I have initialized an integer n, that is the size of an array, and I have basically initialized one my map. Okay, and now I am basically incrementing the count of every distinct elements in the my map, and if n is less than equal to 2, then we will simply print yes. Now we will go to different cases according to the size of the map. If the size is 1, then it will be yes. If the size becomes 2, then they may or may not be possible. If the difference of the uh, count of two distinct elements is greater than 1, then we will print no, else we will print yes. And if the size of the my map is equal to 3, that is the number of distinct elements in the array is greater than 2, then it will never be possible to arrange the elements of the array such that the final array becomes good. Therefore we printed simply no. Okay, you can see the solution, and this is my solution for the problem A. Thanks for watching.